Good evening. Coming up next, we have Hao-En Huang to talk about open source large language models optimization. Let's give him a warm welcome.
Thank you. So greetings, everyone. Glad to attending Hong Kong Open Source Conference 2024 today. So I'm Hao-En Huang, a senior developer advocate for AWS, and my focus research area about the large language models, generative AI, and machine learning and data science. And today's topic, I think, is a cutting-edge topic about the large language model optimization on AWS. As we know, generative AI have captured the imagination of developers worldwide. So with some maybe in some projects or in some applications, many of the developers are very interested in how to deploy the large language model in many different scenarios, or you have your own data, you want to train your own model. So that is entering into another area, which is about the fine-tuning your large language models. So today's topic will talk about this. But actually, I last time in Taipei and in Shenzhen, I shared this topic, and in Las Vegas last year, it takes about 1 hour to share this topic. But today I only have 50 minutes, so but don't worry. If I have time, maybe I will go to a New York summit next week, and in New York summit I have 1 hour full session, and if if I have the chance to attending the PyCon 2024, I will share. I'm expecting to share the 1 hour full session with you. But today, 50 minutes. So before we dive into the specific of large language model optimization techniques, let's first understand the importance and the benefit of optimizing large language models. That is why we need to do the optimizations on large language models, why it's necessary, and how can it enhance or provide us the ability to better serving our models in real world scenarios. So to illustrate the challenge of large language models optimization, let us consider the Llama 3 70 billion models as an example. So while model training is a vast and complex topic, we will focus our our discussion on model inference. So you know, model training is another huge topic. So we are not going to talk about model training. So all we talk about is model inference. So large language models primarily rely on transformer architectures, as you know, so which are known to be memory intensive when processing long text sequences. Consequently, memory constraints can become a bottleneck for large language model inference performance. So during the auto-regressive decoding process, all input tokens provided to the large language model generate attention key and value tensors. And these tensors commonly referred to as KV cache, so are stored in GPU memories for subsequent token generation. As an example of the Llama 3 70 billions, we require at least 280 gigabyte memories for just load the initial model weights and nearly 20 gigabyte of additional memories to accommodate the attention cache. So that is the KV cache. This substantial memory demand arises from the model's 70 billion parameters, and the transform architectures lead to store attention cache for token generation, for the next token generation, as you know. So here's a challenge. Let's consider a scenario where you want to perform inference with the memory intensive models like Llama 3 70 billions, which requires about as shown here, about 300 gigabyte memories. However, if you are working with AWS and you use maybe some instance like MLG5 48X large, which only offering 192 gigabyte. So you cannot put the 300 gigabyte Llama 3 models inside the instance, right? So it's a challenge. Okay, so how should we do? In such cases, what's the solution to overcome these memory constraints? So one of the solution is to address the memory constraints of large language models. We call it model compression. Yeah, when considering model compression, there are two primary ways or approaches that can be employed. Number one is just to reduce the number of some layers or some connections within the model. And number two is to decrease precision or weights through a technical, we call it quantization. Yes. So we will focus specifically on quantization today, which involve reduce the precision or weight, maybe from FP32 to FP32 is requiring 4 bytes per parameters, to FP16 or BF16, which is requiring only 2 bytes. So by quantizing the Llama 3 70 billion model to FP16, we can effectively reduce the model size by half, right? From the 280 gigabyte to 140 gigabyte. And now the number is smaller than 192 gigabyte. Seems it works, but do not forget, as our G5 48X large instance, we have 1, 2, 3, 4, 8 GPUs, but each GPUs can providing or offering 24 gigabyte memories. So that's the problem. Although we can do some quantization to let the big models to do the half size, like 140, we cannot put it inside any of the GPU, right? So in this way, what should we do? So actually, we have many. We come to a very interesting topic. Is about optimization large language models, and in that case, we can use some like model partitioning, like we distribute our models or our data across these 8 models. Yeah, that's a way. But actually, this slide, I will show you the whole pictures of how the large language model areas and how they do the optimization works. Like taking the deployment of the previous Llama 3 70 billion models as example, we discussed this challenge when deploying the large language model. So in actually production environment, there are many other even more difficult challenges. So on this slide, from left to right, the first optimization techniques shown here is model combination. Yeah, as you know, model combination in machine learning is a process. I think it's a process of converting a high-level model representation into an optimized a form that can be executed effectively on target hardware, maybe GPU, maybe CPU, maybe some specific ASIC like AWS inferential, AWS trainer, like that. And this optimization performs, they involve some techniques just like some kernel fusion or operator fusion and other methods that enhance performance and resource utilization. And the next is about the next technology is model compression. We have talking about model compression in the previous slides, and it refers to a set of techniques including here quantization and pooling and distillation. Quantization, as we have introduced, like from 32-bit to some 6-bit, maybe to 8-bit or 4-bit. And for model pooling involves removing some redundant and less important weights or neurons from a pre-trained neural model, neural network models, resulting in a smaller and more efficient models with minimal loss in accuracy. And model distillation, in Chinese, we say, in Chinese, this we can translate to 量化, and this is 减资蒸馏, but I don't know how to say it in Cantonese. Maybe you have another word, yeah. In Mandarin, it's 量化减资蒸馏. So it's quantization, pooling, and distillation. So model distillation is a process of like a teacher model and a student model. It is to transfer knowledge from the teacher model, a complex teacher model, to a smaller but more efficient student model. And this process can enable the student model to mimic the teacher model's behavior and achieve comparable performance, while at the same time, it can be more lightweight and computational efficient. And the model partitioning is we have mentioned the model partitioning in the previous slide, and it's a technique that divided large models across or into some small partitions, which can then distribute the data or the models across multiple devices or processors. So enable parallel execution and reduce the memory and computational requirement on a single devices. So, and the last today we will talking about is about the batching. You know, in some real world scenarios, you want to get the high throughput, right? You want the info in your production environment. You use the large language model at the end, and from the front end, you want the high throughput, yeah, to provide it. So some of the large language model researches in the actually this some of the technologies it just happened or their papers just released or published in several months ago or within 1 year. So it's a very new idea to do this, and I think there is more and more papers to talking about all these areas about model combination, model compression, model partitioning, and how to improve your throughput of the large language model output, which is calling about the model batching or dynamic batching. We may do not have time to discuss them today because I think there's only 3 minutes left, right? Okay, but I still, actually I have 60 pages for my, but now just slide 6. So I will skip some papers. Let's skip the quick start part. Yeah, as you know, I'm not sure you know, now it's very easy to deploy a large language model on AWS. Besides, if you know us, if you know something about the SageMake Jumpstart, last year we provided some SageMaker and SageMake Jumpstart to help developers to simplify, to streamline your developer cycle. But this year in 2024, we announced the Emerald Bedrock, which even easy for you to, even you are just a beginner, you know nothing about large language model, you know nothing about Python, you can start with our UI interface, and of course we offer we can offer you the APIs as well to do the to do the work too. So Emerald Bedrock is a platform, and on that platform, many of the foundation models we can put inside, and you can use the universe, or you use the same API. We call it the Converse APIs to across many more models. So maybe in the future we'll add more models inside, but you can still use that APIs as well. So it's magic. I have a blog here, so if you're interested, you can take photo here. Yes, I think my time is up. So, okay, so let me switch to, maybe you will wonder how we can do this, how AWS can simplify all these process for developers. We provided a kind of, which is a large model inference, LMI container, and you see many of the framework here, like MPI and deep speed, Hugging Face accelerator, faster transformer, and even inside the like MPI framework, we can support some very new cutting-edge technologies like flash attention, page attention, rolling batch, yeah, to help you to faster deploying or fine-tuning your large language models. But today we do that. Yeah, and it's very easy to use AWS SDK to configure these models, just like here, option setting, rolling batch, auto, or page attention, setting it to true. So it's very easy for you to now to deploy or fine-tuning large language model on AWS now. So you can invest your time or your people, yeah, if you're a boss here, to maybe you focus on your business, your real business, or you leverage your own your private data to training model or fine-tuning model, and all these difficult works that AWS help you to do. Yeah, and I think this is my sharing today. If you want to know more about the thing, I have the linking account here. You can scan the QR code here, and I think the field of large language models is rapidly evolving, and I will keep you updated on the latest breakthrough over on my LinkedIn page. And thank you. Yeah, thank you.
Thank you, Howard Huang, for a wonderful sharing. If you would like to discuss with our speaker with this topic, you may proceed to the social area outside.
Hello. I want to take a moment of the time, like to give some announcement, I think. Let me set this up.